Hello there, my name is Derek Bingham. I'm a developer advocate at AWS, and welcome to implementing GraphQL security best practices with AWS AppSync. Over the next 30 minutes, I'm going to talk to you about how to best secure and manage your GraphQL APIs running on AWS and AWS AppSync. I'm going to assume that you're familiar with API options that you can run on AWS, and also assume you have some knowledge of differences between GraphQL and RESTful APIs. So let's get started by talking about what it takes to make your API production ready. So I see these as typically the requirements we as developers need to think about to make our GraphQL endpoints ready for our users. First of all, we need to think about protecting access to the API by making sure that only authorized users have access to that API. However, we should still be able to make sure that it can support multiple access patterns, be flexible, and cater to different types of users and different types of systems that may want access to the API. We also want to grant only the specific access that users need and to be as granular as possible with the access that we do provide. Next, we want to protect the availability, making sure that our service is available while providing the level of service that our customers come to expect. We want to meet our customers' expectations by making sure that they are maintaining the uptime of the service, limiting the availability to trusted sources, as well as making sure that bad actors do not impact the service. We also want to be able to block these bad actors and to be able to protect the overall performance of our API by making sure that we can actually monitor what is going on within our API. And we also want to be able to analyze in real time, if we need to, tracing calls for our API, tracing through all the different components and hops that are involved in resolving a field in our schema, as an example. This is also very important. And once we've got all these things set up and figured out, we also want to be able to constantly look to improve our API over time by fine-tuning resolvers and how they access your different data sources to provide the best performance is a good example of how to improve a GraphQL endpoint over time. And finally, once we have got those best practices and implementation details set up, we want to be able to redeploy these changes over and over again with confidence and make sure that every time that we deploy the API, we're also deploying the same best practices into production. So how can AWS AppSync help with these requirements? If you haven't used it before, AWS AppSync is a fully managed GraphQL service that runs on AWS. It helps you build scalable applications that can connect to multiple data sources that you have within your AWS account. It is also a foundational building block that allows you to build a GraphQL API for real-time applications that require offline data access. There are many benefits to AWS AppSync. As well as being a managed service where you don't have to worry about any servers or infrastructure to manage, you can also start by supplying a valid GraphQL compliant schema and just get started right away. AWS AppSync also helps you to connect to data sources within your account, working out of the box with data sources like Amazon DynamoDB, AWS Lambda, and Amazon OpenSearch. And so you can easily connect these into your application. Also with AWS AppSync, it's a great ability to connect to any AWS service by using its inbuilt HTTP resolver. For offline modes, it also supports AWS AppSync can allow you to implement conflict detection and resolution rules. So this minimizes the back-end code that you need to write to handle these often complex scenarios. And finally, and what we're going to delve into today, AWS AppSync also provides a large feature set of enterprise security features that allows you to set up things like MultiAuthorization, access control, integrates with AWSWAF, which is AWS Managed Web Application Firewall, and it also provides the monitoring that you need to actually track the performance of your API. These features, as I say, are what we're going to concentrate on today and how they can be leveraged to improve your API and application. So let's start by talking about protecting access to your API. AppSync allows you to deploy secure and protected endpoints. AppSync always requires some type of authorization to get access to your API. It all allows you to create a GraphQL endpoint with some type of authorization that you need to provide. So in other words, no anonymous public access is allowed. There's always some type of credential that you need to provide to gain access to the API. So AppSync provides a couple of authorization modes. Depending on the type of application you're building, whether it's enterprise or it's startup, if you want to gain access to your API, you may want to choose a different authorization mode for each of these use cases. AppSync supports the following modes, which we'll dive deeper into next. It supports API keys. It also supports OpenID Connect or OIDC and JWT tokens. It supports Amazon Cognito user pools, which also use JWTs. And finally, it also supports granting authorization based on permissions set up by AWS Identity and Access Management Service, or AWS IAM. So you have the flexibility to choose the right authorization modes that help with your particular use case. So as you can see, it's important to understand which authorization mode makes sense in different situations. So let's go into a bit more depth on each. The first mode we'd like to look at is the humble API key. This mode allows you to simply specify a header in your AppSync request. This header is called the X API key and specifies a value of an API key that you can set up on your AppSync API. So you can, for example, go into the AppSync console, go into settings and set up an API key and give it a value, or use the default provided. This is a fairly simple but efficient mode to use. It's a great mode to use when you're just getting started with AppSync and you're building out a demo. Or it's also a great mode to use where you're providing what are essentially public APIs, and as such have no specific authorization requirements to implement, nor any type of granular access control that you need to implement either. It's also a great mode to use for business to business or machine to machine use cases. So let's say, for example, you have some third-party partners and they are accessing your APIs, and you want to provide them with different levels of access. You can specify then different API keys for each of those partners. Or similarly, you have remote servers that are accessing your APIs and you can securely deliver the API keys to those servers. API keys all make sense in these situations. Next, let's look at the Cognito user pools. This is a great tool to use if you have an application where users are signing into the app with the Cognito user pool, and then using JSON Web Tokens or JWTs that they receive from Cognito user pool as a reply, then you can gain access to the API. So a great mode to use if you're using an authenticated user inside an app. This mode is also good if you need to connect social identities, as that is another one of the features that are built into Cognito. Also, if you're going to build an app that also interacts with AWS services, then Cognito user pools is probably what you want to use, as you can exchange Cognito user pool generated JWTs for actual AWS credentials. If you have an application also going to interact with something like an AWS service like Amazon S3, then the Cognito user pool mode is most likely what you want to use too. Additionally, with the Cognito access mode, you can also implement granular access controls using directives. So what you can see here, for example, on the left, is a post field on my query type that's being specifically controlled. I'm using the AWS Auth directive to specify which Cognito groups should have access to this post. So in this case, I don't need to write any specific business logic. I just use the directive in the field to specify who has access. Also, when I write my resolvers, I can write additional business logic by using the identity of the Cognito user to work out what type of access that user should then have, as it's all available to me as a developer in the resolver, which is a very nice way of encapsulating all that logic. Next, we're going to look at the OpenID Connect Authorization mode, or OIDC. This is similar to Cognito user pools, essentially because we are talking about JWTs to get access. So this is good when you have an application that already has a user directory. So you might have an external OIDC identity provider. You can then set up AppSync to interact with that OIDC and to properly identify and authorize requests with the JWTs that are returned from that provider. This works well with apps where you need to authenticate users and where you have an existing user directory. Other things to mention here, the one difference with Cognito user pools is Cognito user pools can actually be used to exchange AWS credentials. This is not something that you would be able to implement with your OIDC identity provider. So it's a good mode to use, but just keep in mind that you wouldn't be able to interact directly with other AWS services. However, just like Cognito user pool, you can implement your granular access control using the claims that are available in your identity object that you made available to your resolvers in AppSync. In this example, we're implementing something very similar to what we had in the previous slide, with Cognito using it to group information into claims for the specific identity. Like before, we pull up groups, in this case, bloggers and readers, and we just go through the list of groups to see if they belong to one of these particular groups. And if they do, you can then grant them access. If they do not belong to any of these groups, you can use the utility method util.unauthorized to reject the request. The last mode that we'll look at is the AWS Identity and Access Management mode, or IAM. This is the mode that you use where you essentially use IAM to write permissions that grant access to AppSync. This is a great mode to use if your backends running on AWS that are going to be accessing your AppSync API when you're using AWS credentials. Or if you're using IoT systems that are using AWS credentials, as an example, you can then use your role that contains the policy to sign your request for AWS AppSync, and AppSync will then validate the request and make sure that you're authorized to access the fields and types that you want to access. You can also get very granular with these permissions too. As you can see in this example, IAM policy, you can specify which fields the user in the policy has access to. So this is the mode that I would recommend using if you're accessing from an EC2 instance, because they use instance profiles, or if you're using an AWS Lambda function to access the API. So here you can also specify the permissions that the Lambda function should have. So all of these modes work well by themselves, but AppSync also allows you to use one or many of these modes at the same time on a single API, which is great for your application's flexibility. This means that you can do multi-authorization on your API and grant different types of access depending on who or what is accessing your API. So you could have, as shown in this example, an AppSync system where you have a Lambda function that's running and periodically updating your API. And that Lambda function uses an IAM role to gain access to AppSync. Now on the client side, your users are interacting with the API using Cognito. And maybe you also have an IoT system that then uses AWS permissions as well to gain access. Or maybe you also have users that are logging in through their OIDC IDP and then using the generated JWTs to get access to your AppSync API. So you can specify additional providers as needed. You select the default mode and then you specify additional providers. So you can get pretty granular as you specify which types of mode have access to the fields. This multi-authorization setup is very powerful. So let's see how we can implement some of the ideas I've just addressed. For the demos in this talk, I'll be using the AWS CDK to provision my backend services. We use the CDK as you can use it to build in best practices and also use the infrastructure as code to mean that these are repeatable across all your environments, which, as I mentioned, is an important step to making your APIs production ready. So let's look at the demo. So here I have Visual Studio Code and I have my CDK project all provisioned, and you can see it's a typical CDK project on the left hand side. You can see all of the folders that you expect within a CDK. So if I just check the version, so you can see that this was built with the CDK version 1126. I'll share the location of this code during the talk. So here inside my lib folder and my bin folder. Bin, if you know the CDK, this is the entry point to the CDK code, and all I'm doing here is calling AppSync reference stack. So if I go into the AppSync reference stack, this is a typical CDK stack. So inside it, I've got a stack, and the first thing I'm defining is my Cognito user pool. So this is the authorization mode I'm going to use. As you can see, I specify a pool name, I specify the standard attributes, but what we really want to look out here is how I apply that pool to my GraphQL API, which I've provisioned here. So here, if I look at the schema in my GraphQL API, which is a separate file, you can see that I have a type called to-do, and the to-do type is using two authorization modes, user pools and AWS API key. Also, I have a query, which has got get to do, which is using the AWS Cognito user pool authorization mode, and then list to dos, which doesn't have currently an authorization mode assigned, so I'll be using default. This is the rest of my schema, but for this demo, I'm not going to concentrate on that. So back into my CDK stack. And so that's my schema. You can also see here I define my authorization modes. So my default other authorization mode, which I have to have, is API key. And then I've defined underneath that the additional authorization mode, which is my Cognito user pull. So that's the multiple authorization modes defined. You can see that pull is then passed in, and then I can define my logging config and any additional fields. So here I've got some data sources defined, which is a DynamoDB table and a Lambda function. And these I've wired up to my AppSync API as data sources. So that is the demo code. So let's do a little test to see how those authorization modes will actually work. So here I am in the AppSync console. You can see the authorization modes listed here. First one I've logged into is the Cognito user pull. And so what I can do now is run one of the queries. So if you remember, I have two queries, get to do and list to do. So if I run the get to do query, you can see that it returns an ID as expected. But if I run the list to do's, you will see that I get an unauthorized exception. And that's because I have not added the authorization mode to the list to do's query, which I can check. If I go into my, you can see that, if you remember, this is my authorization modes. And you can see inside my schema, in my queries, in the list to do's, I haven't added the Cognito user pull on the list to do. It's only on the get to do's. So that means that the list to do's will only work for the default authorization mode, which is API key. And that's why I've got the authorization exception. So that, as you can see, is how you can apply different authorization modes to your GraphQL API. So that's authentication and authorization strategies that you can adopt to protect your API. Next, let's take a look at protecting availability of your API. As with Auth, we're just talking about making sure that your API provides the experience that your customers come to expect from it. So with AppSync, it provides DDoS protection for every API that you configure. This means it's built to withstand attacks and can scale accordingly to absorb those attacks. Additionally, it also integrates with AWS WAF to provide additional firewall rule functionality for your API. With AWS WAF, you can actually protect against exploits that impact the security and availability of your API. And the great thing about AWS WAF is it's really easy to configure. So if you haven't used it before, AWS WAF is a web application firewall that runs on AWS. It integrates with services like AWS ALB, Amazon CloudFront, and API Gateway, and of course, AWS AppSync. Again, like AppSync, it's a managed service, so there's no infrastructure for you to manage. There's really a very low operational overhead, as you simply use rules that you write yourself, or use managed rules that are provided by AWS. These are rules that are updated automatically to protect you against the most common threats, like cross-site scripting or SQL injection detection, as an examples. It's highly customizable, so you can use your own rules, or you can also use third-party rules that you can find in the AWS marketplace. So WAF integration really opens up the door for a lot of additional security and protection of your API. Some of the use cases where WAF could be used with AWS AppSync, which we'll go into more detail on this in this section. You can protect your API against flooding and from being overwhelmed. You can turn off introspection in situations where you actually don't need that functionality. And if you're supporting B2B APIs using API keys, you can make sure that your different partners or third-party providers that have those keys do not also overwhelm your API. And finally, you can also limit access to Amazon VPC resources. So let's dive into more detail on each of these scenarios. Protecting against flooding is when we can use WAF as an access control list that you can configure. You can do this by setting up a rule that will actually throttle requests that come from an individual IPs. If they have exceeded a certain rate per 5-minute segment, for example, you can throttle them. So this is a good rule that you can set up to actually protect against flooding or bad actors that may try to overwhelm your API. Next, you can turn off GraphQL Schema Introspection. Introspection is a special query in GraphQL that allows you to discover the schema. It is a big benefit of GraphQL, but you may not want that functionality in production as an example. For some reason, you may want your schema to be discoverable. So you can set up a rule that blocks any request that contains the special underscore schema request. That way, introspection is turned off and that only impacts introspection queries. The rest of the queries are not impacted at all. Next, you can support B2B APIs using the API key. So we looked at some of the throttling rules that you can set up, but you can also set them up in a few different ways. Rather than using API addresses, you can use different API keys that you may have set up on your API. So if you set up different API keys for different businesses, for example, that you're working with, you can then also set up different throttling rules for those different APIs. So that's also a way of configuring different levels of access and different throttling rules for those different API keys. Finally, you can greenlist access to your VPC. So you may have a situation where you have a VPC and you have an AppSync API. Now you only want resources from your VPC, maybe your EC2 instances. You only want those EC2 instances or requests that are originating from inside your VPC to have access to your API. What you can do is to set up a WAF in front of AWS AppSync with a default rule that blocks all incoming traffic. Then you can set up one rule that allows traffic that comes from your NAT gateway elastic IP address. This way, you're blocking everything else and you essentially have a private API that is only accessible from your VPC. So let's see how you can implement some of those protection rules. So here we are back in our demo and we're back in our CDK code in our GraphQL schema. Same schema, haven't changed anything here. So if we go into our AppSync stack, our CDK stack, we have defined a set of rules called WAF config. So I'll scroll down a little bit until I find it. So here is my WAF config, which is a separate stack that I have created. So inside this stack. So if I can jump into it, you'll see this is the stack, and I have passed into it the API, so I can reference everything about the API inside the stack. First, I'm going to set up a list of allowed IPs. So this is a set of IPs that are allowed access into my API. I can then set up different names for these rules, access control list, as I mentioned. We can also log whatever happens. Here, I've also set up some flood protection rules. So this is a particular flood protection rule that, based on IP, it will limit, and then it will scale accordingly. And also, I've implemented the restrict API key as well. So the two types of protections I've mentioned before. Here we lift the XAPI value from the header. If it matches exactly, then we can allow it because it's a known API and we give it a priority. Otherwise, we cannot allow it. And that is the WAF configured in front of our AWS AppSync. So let's see how that works. So here I am back in the console. So I'm using at the minute my API key, so the default authorization mode. So let's run a list to-dos. So you can see list to-dos from this IP is actually forbidden because it was not in the list of allowed IPs. So I get the WAF forbidden exception. But if I run the same query, so the list to-dos query from one of the IPs that I have enabled, which is this IP here, I run the post, which is all GraphQL queries are a post, and I query with the list to-dos. If I run this query now, remember this is an allowed IP, so it's in my allowed IP range, then I should get a result from AppSync. And there's my results, so all the IDs from my data sources have been returned. So that's a nice way of using WAF in front of my AppSync API. So that's how you can protect access to your API. Next, we're going to take a look at protecting performance of your API. The first thing you want to think about when you talk about protecting the performance of your API is making sure that you can actually monitor that performance. Therefore, making sure you understand what's going on with that particular performance of a particular API. AppSync allows you to do that by providing CloudWatch metrics. By default, you can monitor the latency of your API, and you can also monitor the number of requests that are coming in to your API, as well as the number of 400 and 500 errors. AppSync also integrates with CloudWatch logs and allows you to use these logs to actually gain further insight into what is going on with your API. So with the CloudWatch logs, you can do two things. You can create a log insight to do some querying of your logs to figure out what's going on. For example, you can look at the tracing logs to understand the latency that your different fields and resolvers are experiencing. And if you find that insightful, you can then choose to create metric filters to create specific latency metrics for fields that you want to monitor closely in your schema. Now, once you've created these metrics, you can also set up alarms against them, so you can be notified if some of your field resolvers, as an example, are taking more than expected to resolve particular requests. And then based on these alarms, you may choose to take different actions. Maybe you want to introduce something like a cache, or maybe there's some fine tuning that you need to do to perform on your resolvers to improve their overall performance. That's monitoring and how you can use it to improve your API, but sometimes you need to perform some real-time tracing of that API to find out what's really going on. You can do that with AWS X-Ray, which integrates with AWS AppSync. AWS X-Ray provides an end-to-end tracing in near real time. It allows you to see how the different components to make up the call chain of your AppSync request behave. It's also a great visual tool that you can use to identify performance bottlenecks. And you can see which component in the chain is actually contributing most to latency. In this example, you have a request that is accessing both Lambda and DynamoDB. And you can then work out which of these components is contributing the most to latency, and then you can take steps to fine-tune. Finally, we can fine-tune and optimize your API with caching. AppSync does provide a cache that sits between your API and your backend resources. So if you run into a situation where you want to provide faster response times to some of your requests, you can introduce this cache. As it's a fully managed cache, you can set it up for full API caching. And at that point, all requests will be cached. So providing that millisecond type of response for all requests coming in. Or you could set up it per resolver caching. You may have some resolvers that you do not want to cache, as the data is often changing rapidly. But you may have some other resolvers where you know that the data does not change that much. Maybe it's a read-heavy system and you want to put a cache in front of one of your queries, so you can turn that on. Finally, you can turn on encryption as well to protect your data both at rest and in transit. So let's see how we would implement those things. Here we are back inside our project, inside our WAF config stack. So what we want to do is have a look at how we're going to configure CloudWatch. So like the WAF config stack, I've created another one, and this is a CloudWatch config stack. So if I go in here, it's a config construct. So here I'm passing in, as well as the API, is the field names. So then I can define a log group based on my API ID. And inside that, I can start mapping fields. So I can log on specific fields inside my schema for my API. I can define where these tracing logs sit. And then once I've defined that, I can also define alarms on those logs. So based on a CloudWatch, I can raise an alarm if a specific threshold has went over, and that alarm can be very granular based on API and field name. So it can alarm me on a particular resolver not returning in time. So let's now see how we'd put all of that we have learned together and built in action in a production system reference architecture. What we have here, we've looked at protecting your accessibility, protecting the availability, and protecting the performance of your APIs. These are the different components you can really help build APIs and get them ready for production. And when you put it all together, you end up with an infrastructure that you can easily deploy on AWS using the CDK. AppSync integrates with these different services to build an infrastructure that's ready for deployment. So here we have AppSync integrating with X-Ray and Amazon CloudWatch, sending logs and then creating latency alarms. AppSync also interacting with different backends like DynamoDB and AWS Lambda where needed, and introducing an AWS AppSync cache to improve the latency and resolve time. Next, we have AppSync integrating with AWS WAF. We have WAF protecting your AppSync API from flood protection, limiting, and blocking introspection queries. This is something that you can build with AppSync and with the different services that interact with AppSync, and is something that you can deploy easily with the AWS CDK. But don't take my word for it. Here's the code from today's demos. Please check it out if you're interested in putting it together yourself. Here are some further resources to help you adopt these practices. My name is Derek, a developer advocate at AWS. Thanks for watching and making it to the end. My Twitter handle is here. Feel free to reach out, and I'll see you next time. Thanks.